Okay, today we're going to look at Lesson 15. This comes from sections 2.7 and 2.8 in your textbook. We're combining them together to just do one lesson and one homework. We have two learning objectives, or I can statements. I can graph linear inequalities, and I can graph absolute value equations and inequalities. So linear inequalities, that's something that you've done before. I know you did it a lot in Algebra 1, but you're going to be graphing a line, and then you have to decide if the line is dotted or solid, and then shade above or below. So that is all review. Graphing absolute value equations and inequalities is going to be a little bit new, but I'm going to talk you through it and show you what to do. And then, in my opinion, the work on Math Excel is actually pretty easy for the graphing. So hopefully it won't be too bad. As usual, I'm going to go faster in the video than I would in person, so feel free to pause and rewind as you need to. If you need to chunk the notes up into smaller sections, feel free to do so. If you want to watch the inequalities portion and then go back and do the Math Excel that matches and go back and forth, again, that's fine also. But I do expect you to write down the notes in your notebook, try the examples, and answer the Edpuzzle questions. All right, so the first thing we're going to look at is graphing linear inequalities. So here are the steps for graphing linear inequalities. The first thing you're going to do is graph your 2 points. If your equation is in standard form, or your inequality is in standard form, meaning it looks like this, y equals mx plus b, you're going to graph b, or your y-intercept, on the y-axis, and that's up and down. And then from that point, so you start at the point that you made, use your slope, your m, go up or down and right to make your second point. Okay, once you get your second point on there, you can move on to step 2. If it's in standard form, you have to find your x and y intercepts and then graph those. And so what we do is, you did this in previous assignments, but if you're finding x, we know y is 0, so that disappears. You solve this one step and you get x. If you're solving for y, the x disappears and you solve that little equation for y. Those are your intercepts. You plot those on the graph. After you get your 2 points, you have to decide what kind of line to make. Now, back when we were just solving inequalities and putting them on the number line, you had open and closed circles. So we have to translate that to 2 variables on a coordinate plane. So we have to have a closed line and an open line. So for solid, a solid line is the same as a closed circle. You have the equal to's. Okay, that means those numbers are included. If you have a dashed line, or for a dashed line, you have less than or greater than, you don't have any equal to's. That means those are open. Those solutions are not included. So you can do a dotted line or a dashed line, whichever one you like better. I usually say the word dotted, but draw a dashed line. And it really doesn't matter what you do as long as you do one of them. Okay? After you get your line, you have to decide where to shade. Because on the number line, we drew our arrows to the left or to the right based on greater than or less than. So now we have to shade above or below so that we can capture all of the possible solutions to the inequality. So for greater than, we shade above. For less than, we shade below. And that's if it's in the y equals form. Okay, so we made a little note over here. It's a little bit different for standard form. I'll show you how to do that. It's super easy. Okay, but most of your problems are going to be in slope-intercept form, the y equals or the y inequality. And so that's really easy. You just look at the symbol and decide if you're shading above or below. Now, we'll look at some examples. I'll do some with you. I know that you don't have the graphs nice and pretty and printed out. And so it's going to be a little bit different for you. But watch what I do, and because you're going to do the same thing in Math Excel, okay, just with your graphing tools. All right, so number 1, we have y is less than 3x plus 2. So the first thing that I'm going to do is I'm going to pick out my y-intercept. So I know I'm going to make a note, y equals mx plus b. That's my form that these are in. So this is my y-intercept. So I go to the y-axis and I'm going to make a point at 2. Now, my slope is 3, so that's 3 over 1. So from this point, the one that I made, I'm going to go up 3. 1, 2, 3, and over 1. Okay, that's step 1. Step 2, I have to decide what kind of line. Is it going to be solid or dashed? We have less than. It does not have an equal to, so that means it's going to be dotted or dashed, whichever one you want to say. I'm actually, to make my line straight, I'm going to go another, let's see, up 3 over 1. Now I'll make my dashed line. And we have to go across the whole entire graph. Okay, now step 3, I have to shade above or below. So this is less than, so that means below. And if you look at your y-axis, if we know this is less, so we want the side where the y values are less. So here are your smaller y values, so this is the side that we shade or we color in. In Math Excel, you have a little paint bucket that you can just pour out. Okay, but if we were in person, we would use colored pencils, we would color it in. All right, number 2 is very similar, we're still in the slope-intercept form. So this number out here by itself, that's our y-intercept. So I'm going to plot a point at 1. Now, what do you notice? We don't have an x or that number in front. So that means that our slope is 0. And what kind of line has 0 slope? Horizontal, straight across. So I'm just going to go straight across and make a point just to have my second point. Now I need to decide which kind of line. Is that going to be solid or dashed? Solid because of the equal to. So I'll go ahead and do that. And then this is greater than, so I'm going to shade above. So above that line where the y's are greater. Okay. Number 3 is a little bit different. What do you notice here? It just has the x. It doesn't have a y, just has an x, and it starts with x. So that means it's going to be a vertical line. Okay, so it doesn't say anything about the y, so we're going to go to the x-axis, and we're going to make a point at 7. Since it's a vertical line, I'm just going to go up a few and make another point. Now, is this going to be solid or dashed? Solid. And this one, I can't really shade above or below because I don't have that. So we're going to think about less. X is less than 7. On which side are the x values smaller than 7? Left or right? It's the left. So we'll color in this side. Okay. Number 4, pick out your y-intercept is 3. So make a point at 3. My slope is 4 over 1. So I'm going to go up 4 and over 1. I'm going to do it again. Oh, I ran out of room. So let me go backwards. So let me go down 4 and over 1 the other way. Is my line going to be solid or dotted? Dotted, because it does not have an equal to. And am I going to shade above or below? Above, because it's greater than. So my y's are greater on this side, so this is the side of the line that I shade. Okay? So all of those were in slope-intercept form or kind of slope-intercept form. The next 2 are a little bit different. So these are given to you in standard form. So we're going to find our intercepts, graph those, and go from there. So 4x minus 5y is less than negative 20. So first I'm going to find x. So I'm going to cover up the y. And what am I left with? 4x is less than negative 20. I divide by 4, and I get x is less than -5. So I'm going to go to -5 on the x. Oh, wrong way. There we go, and make a point. All right, now I'm going to do the same with my y. I'm going to cover up the x. I've got -5y is less than -20. I'm going to divide both sides by -5. And I turn my symbol around and get y is greater than 4. So I'm going to put a point at 4. Now, look at this symbol and decide, do I need a solid or dotted line? Dotted, because it does not have the equal to. Now, here's the shading. It's going to be a little bit different because we can't just go by this. So we're not going to look at that. We're going to look up here. So x is less than -5. So which side is less than -5? This one. Okay. Look at your y. We need it to be bigger than 4. Which side is your y greater than 4? Up here. All right, so that's the side that we shade. Okay. Number 6, we're going to do the same kind of thing. 2x plus 4y is greater than or equal to 8. Cover up 4y. We have 2x is greater than or equal to 8. Divide by 2, and you get x is greater than or equal to 4. So I'm going to go to 4 on my x and make a dot. Now let's do the other side. Cover up the x. We've got 4y is greater than or equal to 8. And we divide by 4, and we get y is greater than or equal to 2. So I go to 2 on the y. Am I going to have a dotted or solid line? Solid. And let's look at this one. So we have greater than or equal to 4 on the x. So which side's greater? This one. Y is greater than or equal to 2. Which one's greater? That one. So that's the side that we shade in. Okay, so that's graphing your linear inequalities. You have some like this in your math Excel work. Just take your time, take it a problem at a time, a step at a time, and always refer back to the video for help if you need to. Okay, the next thing we're going to look at, the next type of problems is a kind that asks you, is the coordinate point or the ordered pair a solution to the given inequality? So we'll just look through 2 examples. Is 4/5, 0 a solution to 3x plus y is greater than or equal to 2? So what we're going to do here is we're going to label our x and our y. We're going to plug those numbers in, simplify, and see what we get. So we have 3 times 4/5 plus 0 is greater than or equal to 2. 3 times 4/5 is 12/5 plus 0 is just 0. And is that greater than or equal to 2? And if you were to do this, some of your calculators might give you decimals. It might be easier for you to think of a decimal rather than a fraction. But that is 2.4 is greater than or equal to 2. Is that correct? Yes. So your answer to that one is yes. We're going to do the same thing for number 2. Is -2, 5 a solution to -2x plus 2y is less than 10? So we label our x and our y. So we have -2 times -2 plus 2 times 5 is less than 10. So -2 times -2 is 4 plus 2 times 5 is 10 is less than 10. That's 14 is less than 10. Is that correct? No. So your answer is no, that's not a solution. And that's all you're doing there. Now, you could see, I don't think there are any like this in Math Excel, but occasionally you might see a problem like this. Is blank a solution to, and then it'll show you a graph. So in that case, you would just find that point on the graph and see if it's in the shaded region or on the line. Okay, now we're going to talk about absolute value equations. So this is a little bit new. So the parent function of an absolute value equation is y equals the absolute value of x, or you can write it in function notation as f of x equals absolute value of x. Those mean the same thing, okay? So a parent function is the most basic form of the function, okay? This is the simplest absolute value function you can have. Just y is the absolute value of x. Here is a table of values for the parent function. So if you plug in -2 for x, the absolute value is 2. Absolute value of -1 is 1, 0 is 0, 1 is 1, 2 is 2. So that same pattern keeps going on and on forever. So basically, it's a V shape. Absolute value is always in the shape of a V, okay? And make sure it has that sharp edge, not curved. Quadratic has a curve. Absolute value is that very sharp point, okay? Now, because of this pattern, it's the same on both sides of the V, okay? So like on the right, you're going up 1 over 1. Same thing is happening on the left. It's just mirrored, okay? And that should always happen because it's absolute value. We know you can take the absolute value of -2 and 2 and get the same thing. And -1 and 1, you get the same thing. That's why it makes that V shape. So all of the absolute value functions that we're going to look at today have this same shape. They're just going to be moved around a little bit. They could be moved to the left or to the right, up or down. Okay, here's the general form of an absolute value equation. So you're always going to have y, the absolute value bars, and x, but you can throw in some other constants and change things around. If you have a number in front, that gives us a dilation. That makes it fatter or skinnier, okay? You can have a number on the inside with x, and that moves it right or left. Now, it's the opposite of what we think. This is very, very similar to our point slope form that we were working with a couple lessons back. We've got that x minus in parentheses. And so remember, you can't trust an x. It's the opposite of what you think. So if you see a minus a number, you're going to go to the right. If you see plus a number, you're going to go to the left. And again, that's opposite of what we think. But remember, you can't trust the x. You can't trust your x, okay? You can also have a number added or subtracted out on the end. If you have a positive number, you're going to move it up. If you have a negative number, you're going to move down. So you're taking that basic V shape that we looked at for the parent function, and you're just moving it around on the graph. Now, in your Math Excel work, you're going to have a couple different types of problems. You're going to have to fill out a table of values and then pick the graph that matches. And then we're going to look at just graphing a plain absolute value equation on the graph, moving that V around. Then we're going to look at absolute value inequality. So we'll do that last. Okay, so let's start with example number 1. We have y equals the absolute value of x plus 5. So what we're going to do here is we're just going to plug each of those x values in for x and see what we get for y. So we'll look at the table of values and then we'll look at how that translates to the graph. So the first one we have -3. So the absolute value of -3 plus 5. Absolute value of -3 is 3. So 3 plus 5 equals 8. Do the same thing with -1. That gives us 1 plus 5 is 6. Absolute value of 0 plus 5 is 0 plus 5 equals 5. Absolute value of 1 plus 5 is 1 plus 5 equals 6. Absolute value of 3 plus 5 equals 3 plus 5, and that equals 8. So we see that pattern once again. Those numbers repeat, okay? So on Math Excel, when it asks you to fill in the table, that's all you're doing. Just plug those x values in and see what you get, okay? So that would be the first part of the problem. The second part of the problem would be picking out the graph. Now, if it's multiple choice, you can take these ordered pairs and just see which graph has those ordered pairs. You could also, if it's not multiple choice and you actually have to graph it, you can graph those points, or you can just look at the equation and see how it's been moved. So we have a positive number on the outside. If we go back up to this form, we said a positive number on the outside means we move up. So that means the graph has been shifted up 5. So I'm going to go to that example on my little graphs. And again, I know that you don't have these graphs in your notebook. You can sketch them out, do your best, or just follow along with me. So I could plot each of these points if I want to, okay? Or I can take our original V shape and just move it up 5. So that means instead of being down here at 0, I'm going to go up to 5. Then I'm going to go over 1, up 1, or up 1, over 1, up 1, over 1. I'm going to do the opposite on the other side. And we've got our V shape. And I can connect those and make a line on each side. And there you go. Now, if I had used the ordered pairs, I would have still gotten the same answer, because negative 3, 8 is negative 3, 8. And this is negative 1, 6, 0, 5, 1, 6, 3, 8. So you can do it either way, whichever one seems easiest to you. Okay, here's number 2. We're going to do the same thing. We're going to plug that number in for x. So the absolute value of negative 3 plus 8. Negative 3 plus 8 is the absolute value of 5, and that's just 5. The absolute value of negative 1 plus 8 is 7. And then 0 plus 8, the absolute value is just 8. The absolute value of 1 plus 8 is 9. The absolute value of 3 plus 8 is 11. Now, on this one, again, we can just look at those ordered pairs and see which graph has those ordered pairs. Or you might notice that we don't have that nice pattern that we did before. That means that these are only on one side of the absolute value, on only one side of the V. So it might be a little bit more difficult to graph it by the points, but we can look at how the graph has been shifted. So that plus 8 on the inside means we go left 8. So again, we're going to go back to our graphs. Okay, I can use the points if I want to, or I can just move the vertex left 8. So instead of being at 0, we're going to go to the left 8. I'm going to go up 1, over 1 on both sides. And I'll do a little more on this side just so you can see. We didn't have these points over here, but we had negative 3, 5. We had negative 1, 7, 0, 8. Okay, so on this graph, as you can see, we would have had to pick just the right x values to get the rest of the shape. So on this one, it was easier to look at how the graph was shifted versus the actual points. But in Math Excel, you have to fill out the table and graph it on the coordinate plane. Let's do another example. Number 3, we're not going to do a table of values. We're just going to look at how this has been shifted. So we have a negative number on the outside. So that tells us we're moving down 2. So instead of being at 0, 0, we're going to go down 2. And we'll go up 1, over 1 on each side. Connect your points to make a line on each side. And there you go. Okay, the last thing we're going to talk about is absolute value inequalities. For absolute value inequalities, we're going to do all the stuff that we just talked about with absolute value equations, except when you graph them, you're going to have a solid line or dotted line or dashed line. Remember, solid has the equal, dashed does not. And then you're going to shade above or below. If it's greater than, above. If it's less than, you shade below. So we'll look at 2 examples of this on a graph, because I think you have some multiple choice questions like this. So number 4, let's look at how that would be shifted. It's -1 on the inside, so that means we're going to go to the right 1. So go over 1, so to 0, 1, and then you're going to make some points, so up 1 and over 1 on both sides to make that V shape. All right, is it going to be a solid or dotted line? Solid, so you'll make your nice regular lines. You've got to go across the whole graph, especially for the inequality. All right, now is that less than or greater than? Less, so we're going to shade below. So everywhere below the shade. Okay, we're going to do the same kind of thing on number 5. This time we have a +2 on the outside, so that tells us we are moving up 2. So make your shape. Okay, now do I need a solid or dotted line? Dotted, because there's no equal to. So you can do one of 2 things. You can keep making the dots, and that works as your line, and mine's not super straight there. Or you can make dashes. Either one, and I know that looks kind of funny, but I'm just showing you how you can do either way. Is it greater than or less than? Greater than, so we shade above. There you go. Now, I know that this video and this section has had a lot of information, and it's a little bit longer, and I apologize for that. I tried to go through it as quickly as I possibly could, but make sure you take notes. Make sure you look at the examples. Use this to complete your homework 15 in Math Excel. If you need my help, please let me know. Hit Ask My Instructor, send me an email, ask me in the Google Meet, whatever you need to do. Have a great rest of the day.